Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on Mathematics Grade 11, Paper 2. This was written in June of 2024 and it comes from the Free State Provincial Department of Education. And it was out of 100 marks and it was 2 hours long. First, let's take a look at some of the instructions and information. This is what I want to bring to your attention. If necessary, round off your answers correct to decimal places. Diagrams are not necessarily drawn to scale. Keep that in mind. Write neatly and legibly, and answers only will not necessarily be awarded full marks. So use all your rough work. Write it where you write all your answers because it could earn you more marks than you could get without it. And this is what the paper looked like. So we've got question 1, that was analytical geometry. This is question 1. And then we've got question 2, still analytical geometry. And then we've got question 3, which was trigonometry. There is your question 3. I'll have chapters in the video, so please you can just jump to whatever chapter you prefer to work on. And then we had another one. There we go. And this is question 4 was trigonometric functions. And then question 5 is analytical geometry. There it is, circle geometry, same as question number 6, the last one. And that was the last of the questions that we looked at. Out of 100 marks, you can pause any or jump to any chapter that you would like, or question that you would like to focus on. So let's start. Question number 1. PQRS is a quadrilateral with vertices PQ, R, and S. P is on the x-axis, there is P, and Q is on the y-axis. There we go. Question 1.1. Determine the lengths of PS and RS. We're going to have to use the distance formula for this one. Let's first copy the coordinates of PS and R. So that's 1.1, question 1. We're looking for PS and SR. Question 1, 1.1. We're looking for calculate PS and RS. All right, let's get the coordinates of P, R, and the coordinates of S. All right, the coordinates of P are, let's go back, -5, 0. So that's -5, 0. The coordinates of R are 3, -2, 3, -2. And the coordinates of S are, let's go back, -2, -5. -2, -5. Now let's calculate. All right, the length of RS, always write the equation because you get marks for that. And always substitute before you work out the answer because you get marks for that as well. So that will be x squared, x2 minus x1 all squared plus y2 minus y1 all squared. All right, now we substitute. Okay, I'm going to do the first one the long way by hand without a calculator first, and then we'll do the second one with a shortcut method using a calculator. So that's x2. So we're calculating RS. Okay, let's calculate RS, not PS. RS will be 3 minus -2. 3 minus -2 all squared plus, and the y1s will be, that's RS, will be -2 minus -5. -2 minus -5, that's all squared. All right, that gives us, that is 3 minus negative that is 2. So that will be 3 plus 2 plus, that is negative 2 plus 5 all squared, which gives us 2 plus 3, that is 5, so it's 5 all squared. And then we've got plus, that is 3 all squared over there. So that is 25 plus 9, which gives us 34. So that is the square root of 34. That is the size of RS. Let's calculate the size of PS using a calculator this time. The size of PS, same formula, always make sure that you write the formula down. Right. So that will be x2 minus x1, sorry, all squared, plus, in bracket, y2 minus y1 all squared. Alright, so we're going to substitute. Okay, let's substitute. That is, okay, PS. So PS will be negative 5 minus negative 2. Negative 5 minus negative 2 all squared plus, and then the y's will be PS 0 minus negative 5 all squared. 0 minus negative 5 all squared. Take out a calculator. Okay, let's take out a calculator. That is square root of, okay, let's go, negative 5 minus negative 2. So that will be negative 5. Negative 5 minus, open bracket, negative 2 all squared. Okay, this is all squared plus, then open bracket, we have 0 minus negative 5 all squared, 0 minus negative 5 all squared, and that will give you square root of 34 as well. And that's the shortcut way of calculating the same thing, which I recommend. Just don't make mistakes because you could end up getting the answer wrong. So we've got RS and PS are equal, both equal to square root of 34. Okay, they are equal, square root of 34. That is also square root of 34. Next question. Calculate the coordinates of M, the midpoint of PR. PR, the midpoint, take a pencil and a ruler, pencil that in. We're going to change the color. All right, there is the midpoint. The midpoint of, okay, it's going to be somewhere there. We're looking for the coordinates of this midpoint, M. I'm going to call that midpoint M. We're supposed to calculate the midpoint of PR, the coordinates of PR, the midpoint of PR. That's 6.2. What are the coordinates of M, which is the midpoint of PR? The midpoint of PR. All right, the x-coordinate of any midpoint is the sum of the x-coordinates of the 2 points flanking it divided by 2, and in this case that will be P, R, P, and R there. So the x-coordinates are negative 5 and 3, negative 5 and 3, We add them together over 2, and that gives us negative 2 over 2, which is negative 1. Next is, okay, same story for the y coordinates, the P and R. Y coordinates are 0 and negative 2. The y coordinates are 0 and negative 2. That is the y coordinate of the midpoint. So that will be PR. That will be 0 and negative 2. 0 plus negative 2 all over 2, and that is equals to negative 2 over 2, which is negative 1. So therefore the coordinates of the midpoint are, therefore the coordinates of the midpoint of PR are negative 1 and negative 1. And that's how you find that. Next, 6.3. Oh, sorry, that is 1.3. Sorry about that. 1.3, show that the value of t equals to 3 if it is given that PR and QRs bisect each other, the value of t. Alright, so there is the other diagonal there. Alright, perfect. So we're supposed to show that this is t is equals to 3. Alright, the midpoint, which with the coordinates negative 1, negative 1, is the meeting of point S and Q, just like it is the meeting of P and R. Now, to find T, we need to add the y coordinates of the 2 points and match it to the y coordinate of the midpoint. So, the y coordinate, that is 1.3. The y coordinate of the midpoint is, the y coordinate of the midpoint is y1 plus y2 over 2. We know that it's negative 1, and y1 is, okay, that is on P. Okay, let me go. That will be S. Y1 is negative 5, and then the other one is T. Negative 5 plus T equals to all over 2. That is equals to negative 1. So what we do is we multiply both sides by 2. That leaves us with negative 5 plus T on the right hand side. And that is negative 2 equals to negative 5 plus T. Take the negative 5 to the left hand side. Negative 2 plus 5 equals to T. 5 minus 2 gives us 3, and that's how we prove that. Done. Okay, so this is supposed to be 1.2. Sorry about that. Okay, let's fix that. That's 1.2. Okay. 1.3, 1.4. So we're done with 1.3. We've shown that. Therefore, the coordinates of Q are 0 and 3. Question 1.4. Determine the gradient of PQ. The gradient of PQ. Right. Here are the coordinates of Q again, 0, 3. Gradient of PQ. Right. The gradient of PQ. 1.4. The gradient of PQ. Alright. This is equals to y change over x change. Y2 minus y1 over x2 minus x1. And that will be equals to what? PQ. Q has the coordinates 0, 3, and P has the coordinates negative 5, 0. So 3 minus 0 over 3 minus 0 all over 0 minus negative 5. 0 minus negative 5. Okay, that is equals to 3 over 5. And that's the gradient of PQ. Therefore, the gradient of PQ equals to 3 over 5. Next question, that is 1.5. Calculate the size of angle PQR. The size of angle PQR. Okay, let's first see if QR is not perpendicular to PQ. Let's find the gradient of QR. All right, let's find the gradient of QR to see if these two are not perpendicular. That will be equals to y2 minus y1 over x2 minus x1, which is equals to QR, Q3 minus negative 2. That is 3 minus negative 2 all over. Again, the x coordinates are 0 minus 3, QR. 0 minus 3. That gives us 3 plus 2 over negative 3. And that is equals to 5 over negative 3, which is negative 5 over 3. Now let's multiply this together. If they give us negative 1, then it means that the two lines are perpendicular. So let's multiply the gradient of PQ with the gradient of QR. MPQ times MPR. MQR. PQ and QR, sorry. The gradient of PQ is 3 over 5. The gradient of QR is negative 5 over 3. So that's 3 over 5 times negative 5 over 3. The 5's cancel out. And the 3's also cancel out. That leaves you with negative. That is negative 1. If the gradients of two lines are negative 1, that means that the lines are perpendicular. Therefore, PQ is perpendicular to QR. Therefore, line PQ is perpendicular to QR because the product of their gradient gives you negative 1, meaning that therefore, where do they meet? PQ and QR. PQ and QR form the angle PQR. Therefore, that angle is 90 degrees. Therefore, angle PQR is 90 degrees. Last question, 1.6. What type of a quadrilateral is PQRS? Justify your answer. We've already proven that these two sides are equal, and all the angles obviously will be 90 degrees. So we've got the angles 90 degrees, interior angles are 90 degrees. The diagonals bisect each other, all sides equal. If you don't believe me, you can calculate PQ, QR. It's up to you. You can do that. Just quickly freeze this and calculate it, and just to prove to yourself. All right, this PQRS is a square. PQRS is a square, and these are the reasons. Reasons. I'm gonna list all other reasons. Number 1, all sides equal. All sides equal. That's the first thing. And number 2 is all interior angles equal 90 degrees. And then the last thing is that diagonals bisect. That's a square. Diagonals bisect each other. cut each other into two equal pieces. We are done with this question. Let's move on to the next question. Question number 2. In the diagram below, A, B, and C are vertices of triangle ABC, A, B, and C. Q is the x-intercept of the line AC. There is Q. Theta is the angle of inclination of AC. There. And angle BAC is equals to 37 degrees. There is angle BAC. 2.1. Determine the size of angle theta. Right, notice that AB is parallel to the y-axis because the x-coordinates are exactly at the same point on the x-axis. All of them are lined with one point on the x-axis, so meaning that this line is parallel to the y-axis. AB is parallel to the y-axis, meaning that therefore this angle is 90 degrees in the triangle. AB parallel to y-axis. This is question 2.1. We're on question 2.1. Okay, AB, we're looking for the size of angle theta. AB is parallel to the y-axis. Therefore, angle A, okay, A what? Okay, let's call that Q. No, let's call that D. Let's call this point D. Angle ADQ will be equal to 90 degrees. Therefore, angle ADQ equals to 90 degrees. Meaning that, therefore, this angle, which is on the same straight line with theta, angle DQA will be equals to the remainder of that. Therefore, angle DQA will be equals to 180 degrees minus 90 degrees in bracket plus 37 degrees. And the reason is sum of angles in a triangle. Sum of angles in a triangle. That is equal to, take out a calculator, 180 minus, open bracket, 90 plus 37, and that gives us 53 degrees. That is 53 degrees, so we've got 50 degrees, that is that angle. Now, let's find, this is 53 degrees. Now let's find theta. Theta lies on the same straight line as this angle, 53 degrees, therefore, the sum of the two will be 180 degrees. Okay. Theta will be equals to 180 degrees minus 53 degrees. And the reason is angles on straight line. That is the reason. Angles on a straight line add up to 180 degrees, and that will give us 180 minus 53. 180 minus 53. That will be 127 degrees. And there is the size of theta. 127 degrees. That is the size of theta. Calculate the equation of line AC. Now that we've got the angle theta, we can use that to find the equation of the straight line, all right, AC, meaning that we can find the gradient. All right, that is 2.2. Okay, equation of AC. Supposed to find the equation of AC. That will be in the form y equals to mx plus c. First, let's find the gradient. The gradient of AC can be found by using the tangent of 127 degrees. Which is equals to tan of 127. That is equals to negative 1 comma, that's round that off correct to 2 decimals. That will be negative 1 comma 3233. That will be negative 1 comma 33. Therefore the equation so far is negative 1 comma 33x plus c. Point A lies on the line there with the coordinates negative 2, 4. So let's substitute that so we can find the rest of the equation. A with the coordinates negative 2, 4 lies on AC. Therefore, let's substitute. Where there is y, we put 4, the y coordinate. Where there is x, we put the x coordinate, which is negative 2. Negative 2 plus c. Therefore, 4 will be equals to, that will be positive 1 comma 33 times 2. 1 comma 33 times 2, it should be negative, I'm just lazy to, that is 2 comma 66. So that is 2 comma 66 plus c. Take this to the left hand side, take this to the left hand side, so we can have c on its own. 4 minus 2 comma 66. All right, take out a calculator, and that will give us 4 minus 2 comma 66. 4 minus 2 comma 66, and that is 1 comma 34. 1 comma 34. Therefore the equation of AC is y equals to negative 1 comma 33. Y equals to negative 1 comma 33x plus 1 comma 34. That is the equation of AC. Next question, which is 2.3. Next question. Calculate the coordinate of Q, the x-intercept of AC. AC has the equation negative 1 comma 33x plus 1 comma 34. Now we know that the coordinates of Q will have 0 as a y coordinate because it's on the x-axis. So we're looking for the x coordinate of that. It lies on the line AC. So what we do is we find the x-intercept. The x-intercept, to find the x-intercept, we make y0 from that line. Make y0. So we substitute 0 into the equation of that straight line. 0 will be equals to negative 1 comma 33x plus 1 comma 34. Take this to the left hand side, this to the left hand side, so that becomes 1 comma 33x equals to 1 comma 34. And now what we do is we divide both sides by 1 comma 33. So that will be 1 comma 33. Take out a calculator. That will be 1 comma 34 over divided by 1 comma 33, and that will give you 1 comma 007, which is approximately 1. So that gives us 1 comma 000 blah 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 7, and so on and so forth, which is approximately 1. Therefore the coordinates of Q are 1, 0, and there you go, pencil that in. Therefore, the coordinates of Q are 1, 0. And that's how you find the coordinate. Yeah. Therefore, their gradients are equal. Therefore, the gradient of AQ is equals to the gradient of QC, or the gradient of AC for that matter. Which gradients do we have? We've got the gradient of AQ. We can find that. Do we have the gradient of AC? I think we do. Let's go back and check. The gradient of AC. Yes, we do have the gradient of AC. The gradient of AC, we just calculated. There is the gradient of AC. That's negative 1,33. So the gradient of AQ will be equals to y2 minus y1 over x2 minus x1, and that is equals to the gradient of AC is already negative 1,33. All right, so AQ, the coordinates of Q are 1, 0, and the coordinates of A are negative 2, 4. All right, the coordinates of A are negative 2, 4. And the coordinates of Q are 1, 0. Just wanted to. All right, let's use that. So that will be 0 minus negative, 0 minus, to be 0 minus 4. Therefore, 0 minus 4 over the x coordinates are 1 minus negative 2. 1 minus negative 2. That is equals to, all right, what are the coordinates of, C? All right, that will be, okay, the coordinates of Q, C, that will be negative 4 minus 0 over P minus 1. Negative 4 minus 0. Negative 4 minus 0 over P minus 1. Let's see. Just to be sure. Yes. That's P's. Yeah. QC. All right. P minus 1. And that gives us negative 4 over 1 plus 2 equals to negative 4 over P minus 1, okay, which is negative 4 over 3 equals to negative 4 over P minus 1. Multiply both sides, cross multiply. All right, that will be negative 4 times P minus 1 equals to 3 times negative 4. Negative 4P plus 4 equals to negative 12. And therefore, negative 4P equals to negative 12 minus 4, which gives us with negative 16. Now we divide both sides by negative 4, and that will give us 4, positive 4. Coordinates of C. Therefore, the coordinates of C are, the coordinates of C are therefore P minus 4. Those are 4, negative 4. This was question 2.4. Question 2.5. All right. go back. Determine the equation of the line parallel to BC and passing through point A. The line parallel to BC must be parallel to BC. All right, let's draw BC. There is BC and it must be passing through. This is the line parallel to BC passing through A. Okay, there is the line parallel to BC passing through A. Okay, parallel to BC passing through A. First of all, we should know what the gradient of BC is. The gradient of BC should be easy to find. Let's find the gradient of BC. Oh, that should be easy. So the gradient of BC, let's use the coordinates of B and C. The gradient of BC, this is the same as the gradient of the line. So when we find the gradient of BC, that will give us the gradient of the line that we're trying to find the equation of. Okay, the coordinates of B are -2, -1. That's y2 minus y1 over x2 minus x1. The coordinates of B are -2, -1. Okay, let me just double check. Correct. All right, let's go back. Let's find the gradient of BC. That will be equals to -1 minus 4 minus -4 over -2 minus 4. That is -1 plus 4 that's minus -4, then -2 minus 4. That is 3 over -6, and that gives us -1/2. That's the gradient. Therefore, the line so far will be equals to -1/2 x plus c. In order to find the rest of the equation, we just substitute the coordinates of B. The coordinates of A, sorry, because that's what the point passes through. Point passes through A with the coordinates -2, 4. The line passes through A. Let's go. Let's create a new page. The line passes through A. The line passes through A. Line passes through A. Through A with the coordinates -2, 4. Therefore, 4 equals to -1/2 times -2 plus c. Let's fix that. Let's multiply out. Simplify. That will be, the negatives cancel out. The 2's and the negatives cancel out, so that leaves us with 1. That will be 4 goes to 1 plus c. Therefore, 4 minus 1 equals to c, meaning that 3 equals to c. Therefore, the equation is y equals to -1/2 x plus 3. And that's how you find the equation of the line there. And that was the last equation, the last question on 2.5. Remember, when parallel lines have got equal gradients, parallel lines equal gradients. Perpendicular lines, the gradient, the product of the gradient is -1. M1 times M2 will be equals to -1. Just keep that in mind today. Next question, trigonometry. Question number 3, 3.1. If theta equals to 89.4 and alpha equals to 1.22, evaluate the following. Round of answers correct to 3 decimals. This is where they say correct to 3 decimals. Keep that in mind because that's important. It's an important instruction. 3.1.1, sine of alpha. All right, so question 3. Question 3. And then we'll go 3.1, 3.1.1. We're supposed to calculate the sine of alpha. It will be equals to the sine of, what is the angle? Let's go. Sine of 122. Sine of 122 degrees, and that is equals to, take out a calculator, sine of 122. Sine of 122 degrees, and that is equals 0.848 because they said we must round off correct to 3 decimals. That's what we get. 3.1.2. And this one we're supposed to calculate tan of alpha over cos squared theta plus alpha. Tan of alpha over cos of theta plus alpha, and that must be squared. Alpha is 122. to 2 degrees, and then theta is cos square of theta, that is cos of theta is, let's go back, and theta is 89.4. 89.4, so that will be 89.4 plus 122. And that must be squared. All of that must be squared. Let's extend this line. All of that must be squared. Okay, so take out a calculator. Let's calculate that. That will be common fraction button. Tan of 122 over, there is, open bracket, cos of, all right, 89.4 plus 122, and that, all of that at the bottom must be squared. That's what we're supposed to calculate, and that gives us negative 2,197. Negative 2,197. Negative 2,197, and that's your answer there. Next question, 3.2. If 3 tan beta plus 2 equals to 0 and sine of beta is greater than 0, determine without the use of a calculator and with the aid of a sketch the value of the following. All right, this is clue number 1. Clue number 1. Clue number 1, and this is clue number 2. So we must find a way, whatever this is must be at the same place where sine of beta is positive. Okay, let's go. 3 tan of beta plus 2. Let's figure out whether our tan is positive or negative. 3.2. Okay, 3 tan of beta plus 2 equals to 0. Okay, let's go back there and just, yes. All right, let's figure out what the situation with tan is first. All right, so that will be 3 tan of beta equals to negative 2. Take it to the right hand side. Now divide both sides by 3. That will leave you with negative 2 over 3. But remember that tan is y over x. So one of these will be negative. Which one is going to be negative will depend on the second condition, clue. The second clue says it must be where the sine of beta is positive. Okay, clue number 2, sine of beta must be positive. All right, let's look at the cast diagram. The cast diagram will give us a clue exactly where that is. All right, the cast diagram. All right, according to the cast diagram, okay, our 10 is negative where? In quadrant 2 and quadrant 4. Our sign is positive in quadrant 1 and quadrant 2. Now, where both of these conditions are met is quadrant 2, where 10 is negative and sign is positive. So this is the quadrant that we settle on. Now let's draw the shape with. All right, this is the little triangle. So our x coordinate will be negative, so meaning that our x is the negative part, the negative bit. So the coordinates of this point will be negative 3, positive 2. There. Now, okay, let's draw that. All right, let's draw this triangle in a bigger way. Okay, so the y coordinate, the x coordinate is negative 3, the y coordinate is positive 2, and now we need to find the hypotenuse because it's important. All right, once we figure out everything, the hypotenuse r squared equals to x squared plus y squared, and the reason is Pythagoras. That's how we calculate, because to calculate the cost we're going to need this hypotenuse. So now our x is negative 3, our y is positive 2. Negative 3 all squared plus positive 2 all squared. That gives us 9 plus 4, which is 13. Now, therefore, the hypotenuse will be square root of 13. Therefore, the hypotenuse r will be the square root of 13. Remember, the hypotenuse can never be negative. Now, let's calculate whatever it is that they wanted us to calculate. We've got our x, r, and y. Now we can calculate. 3.2.1. Let's go. Calculate cos of beta. All right. Cos of beta will be equals to, that is x over r, and our x is what? Our x is equals to, so this is square root of 13. Our x is negative 3. Our r is square root of 13. Negative 3 square root of 13. And that's your answer there. 3.2.2. We are supposed to calculate what? Let's go back. Square root of 13 cos of beta. All right. Square root of 13 cos of beta. All right. Let's see. Minus 13 sine squared beta. Minus 13 sine squared beta. All right, that will be equals to square root of 13. Cos of beta, we've already calculated that. It will be, just so you can see what we're doing, that will be x over r minus 13. Sine is y over r, so that will be y over r all squared. This x and y's, I just want to illustrate to you how you get the answers right. You don't have to write that. Okay, x in this particular case is negative 3 and r is square root of 13. So that's negative 3 square root of 13 minus 13 in bracket is 2. Over r is square root of 13 all squared. Now these two give us, okay, first before we, these two give us Right. They cancel each other out. We are left with negative 3 over here. Okay. And then that will be, okay, minus 13 in bracket 4 over 13. The 13's cancel out over here too. And that leaves you with negative 3 minus 4, which is negative 7. And that's your answer there. Easy when you know how to do this. Next, 3.3, if sine of 4 degrees equals to m, determine tan of 94 degrees in terms of m. 3.3, if sine of 4 degrees equals to m, the tan of 94 degrees equals to what? That should be easy. First of all, tan of 94 degrees can be written as a combination of 90 and 4 degrees. 90 degrees plus 4 degrees, which is a compound angle. But tan can also be written as sine over cos. So that will be sine of 90 degrees plus 4 degrees over cos of 90 degrees plus 4 degrees, which is equals to sine of 90 degrees plus 4 degrees. Sine of 90 plus 4 lands us in the second quadrant where sine is positive, the originator sign, and it must change into its co-function cos because of the special angle 90 degrees. So that will be positive cos of 4 degrees over cos of 90 plus 4 also lands us in the second quadrant where cos is negative, the originator sign, so it will be negative the co-function of cos, which is sine, and the reduction angle will be 4 degrees. We already have the sine of 4 degrees, which is m, but we don't have the cos of 4 degrees. So what do? Cos of, we use the square identity. Remember, sine squared theta plus cos squared theta equals to 1, meaning that therefore cos squared theta can be expressed in terms of sine as 1 minus sine squared theta, meaning that therefore if we take square roots of both sides, the cos of theta can be expressed as the square root of 1 minus sine squared theta. So this is easy. Take this and just simply come here and substitute that. So that will be square root of 1 minus sine squared 4 degrees over negative sine of 4 degrees. Okay, which is equals to, right, let's have that, which is equals to, wherever there is sine of 4 degrees, we put m. So that will be the square root of 1 minus m squared over negative m. And that's your answer. 3.4. Simplify without the use of a calculator. That should be easy by now for you. Cos of 360 minus x. Okay, cos of 360 minus x. That is question 3.4. All right, let's start a new page. Question 3.4. Cos of 360 minus x times, let's go, tan of 1x minus 180, tan of x minus 180 over, let's go, sine minus x cos of 90 minus x. Sine of negative x times cos of 90 degrees minus x. The whole idea, which is correct, is to start with an angle, so that becomes negative 180 minus x. So everything else we're going to just let stay the same, just for the sake of you seeing exactly what it is that's going to turn into. So that becomes 10 of minus, and now we can switch the order of the angles. 180 minus x all over sine of negative x times cos of 90 degrees minus x. 10 of 90 negative any angle. Okay, let's do a quick cast diagram there. I'm going to delete this as time goes on. Okay. Alright, so that will be 0 degrees, 90 degrees, 180, 270 at the bottom, and that takes us to back to 360 at 0 degrees. So now that we've got this cast diagram set up, 10 of any negative angle will basically land us in the fourth quadrant, which is a quadrant where 10 is negative, so that will be negative. All right, you don't have to do it like the way I'm doing. I just want to show you that that will be negative 10 of 180 minus x. You don't have to do it the way I am doing this. I just want to show you every step of the way what happens. Sine of negative x doesn't have to be this long, like I said, cos of 90 degrees minus x. All right, so that is, all right, so we've got there. Now let's reduce. Now we can reduce once and for all. Let's reduce once and for all. Let's go. 360 minus x, that is in the fourth quadrant. 360 minus x, and cos is positive there, so that will be, it will be reduced to cos of x. Cos of x. So it's reduced to cos of x. All right, times negative 10 of 180 minus x. 180 minus x lands us in the second quadrant where 10 is negative, so that will be negative 10 of x. Next, sine of negative x lands us in the fourth quadrant where sine is negative, so that will be negative sine of x times, now you can see we're reducing everybody at the same time, cos of 90 degrees minus x. That lands us in the first quadrant where every sign is positive. Now, because of the special angle 90 degrees, that cos will change into its co-function, which is sine. And this is how you reduce. So that will be minus negative, that is positive. All right, so that will be cos of x times 10 of x over negative sine of x times sine of x. 10 can be written as sine over cos, so that is cos x at the top over 1 times sine x over cos x. All right, all over minus sine x times sine x. We can have those over 1, but for now it's not important. So let's now cancel these cos's. That leaves us with sine x at the top with negative sine x times sine x at the bottom. This sine x's cancel out, goes once to each other. That leaves us with 1 over negative sine x, which can also be written as negative 1 over sine x, if you prefer. And that's how we reduce that. Next question. Evaluate without using a calculator. So we've got tan of 120 over sine of 115, times. Okay, that's 3.5. Got tan of 120 times sine of 115 all over, let's see, that's all over, let's see, cos 240, cos 205, cos 240, cos 205. Okay, we're going to use the same cast diagram to help us reduce this. All right, whenever they say without using a calculator, that means you're going to need those special triangles, the two right angle triangles with your 60, 30, and 45 degree angles. 10 of 120. So you express all these angles in terms of compound angles involving your 60 degrees. So we're going to need our 60 degrees, 30 degrees, 45 degrees, and 90 degrees, obviously. All right. So now let's express 120, which lands in the second quadrant. It's bigger than 90, but smaller than 180. So it lands us in the second quadrant. And in the second quadrant, this is how we express angles. 180 minus theta, which is the acute angle, or 90 degrees plus theta. But the one that fits best here is 180 minus theta. 120 will be expressed as 180 minus an acute angle. How do we find that acute angle? It's easy. 180 minus that angle, 180 minus 120, and it will give us the acute angle subtracted, which is 60 degrees. So we express that as that. So that becomes tan of 180 minus 60 degrees. 180 minus 60 degrees times the sine of 115. 115 is bigger than 90, but smaller than 180. It's best to express it as 90 degrees plus something. So 115 degrees equals to 90 plus, let's find what the acute angle will be. So that will be 115 minus 90. And that gives us 25. So that is plus 25. Let's go back. That is 90 degrees plus 25. All over. So we have cos of 240. 240 is bigger than 180, but smaller than 270. So it lands us in the third quadrant. In the third quadrant, we express our angles as 180 plus the acute angle theta. So 240 will be 180 plus, to find the acute angle, that will be 240 minus 180. And that gives us 60 degrees. So that will be 180 plus 60 degrees. 180 plus 60 degrees. So that is cos of 180 plus 60 degrees. Times cos of 205. 205. That lands us where? It's bigger than 180, but smaller than 270. So it lands us in the third quadrant. So that will be 180 plus the acute angle. What is the acute angle? Let's see. So that will be 205 minus 180. And that gives us 25 degrees. 25 degrees. So that's 180 plus 25 degrees. 180 plus 25. Now let's reduce. Okay, let's reduce. 10 of 180 minus 60. 180 minus 60, that's in the second quadrant. 10 is negative there, so that will be negative 10 of 60 degrees. Minus 10, 60 degrees times sine of 90 plus 25. It's in the second quadrant, that's positive. Yes, sine is positive there, but because of the 90 degree special angle, we're going to reduce that into its co-function, so that becomes cos of 25 degrees. Over 180 plus 60, cos of 180 plus 60 lands us in the third quadrant where cos is negative. Only 10 is positive there. So that will be negative 10, negative cos of 60 degrees. Times cos of 180 plus 25. 180 plus 25, cos is negative in the third quadrant. So that will be negative cos of 25. The cos of 25s cancel out, not the sines though. And then here the sines cancel out at the bottom. So the negative times negative will give us positive. So that leaves us with, so that's 1 and 1. So that will leave us with negative 10 of 60 degrees over cos of 60 degrees. That's what it leaves us with. Negative 10 60 degrees over cos of 60. So now we pull out the special triangles. You've got the 30 degrees, 60 degrees. Okay, root 3, opposite 60 degrees, 1, opposite, and then the hypotenuse is 2. We don't need to have the other triangle because we don't have a 40-degree angle. So that will be minus all over. Okay. All right. 10 is 10 of 60 degrees will be opposite over adjacent, so that will be square root of 3 over 1. Square root of 3 over 1. And the minus is out there, outside. Then cos of 60 degrees will be adjacent over hypotenuse, so that is 1 over 2. 1 over 2. Now what we do is we use our knowledge of dealing with common fractions. If you've got a over b all over c over d, that can be simplified as a over b multiplied by, you flip this one upside down, d over c. That's exactly what we do here. So that will be negative 1 over negative square root of 3 over 1 multiplied by 2 over 1. Flipping this one upside down, and that leaves us with negative 2 root 3, and that's our answer. Next question. Prove the identity that 1 over 1 minus cos x plus 1 over 1 plus cos x equals to 2 over sine squared alpha. So we start with the left hand side. That's the messier one, right? That's how you prove an identity. Start with the messier side. So that is 3.6. 3.6. Required to prove that 1 over 1 minus cos of x plus 1 over 1 plus cos of x equals to 1 over, okay, let's see, you don't have to, 2 over sine squared x. 2 over sine squared x. I just want to have that in front of me, so 2 over sine squared x. All right, the left hand side equals to 1 over 1 minus cos of x plus 1 over 1 plus cos of x. So we find the LCD. The LCD simply equals to the product of the two, 1 plus cos of x times 1 minus cos of x. So what you do now is you multiply this over all over the LCD. So the LCD is 1 plus cos of 1 minus cos of x times 1 plus cos of x. And the top will be, take this and multiply by each one of the fractions. So when we take 1 over 1 minus cos x and multiply by 1 plus cos of x, 1 minus cos of x. The 1 minus cos of x cancel out, and we're left with 1 plus cos of x. Same story. Take this one, multiply it by the LCD. You are left with 1 minus cos of x. Okay, if you need me to show you, okay, let's do that. 1 over 1 plus cos of x times the LCD 1 plus cos of x. 1 minus cos of x. The 1 plus cos of x cancel out, and you're left with 1 minus cos of x at the and there. So that's how you find that. That is equals to, take off all the brackets and add like terms. Okay, that will leave you with 1 plus 1, that is 2. All right, and then cos of x minus cos of x, those two cancel out. They add up to 0. So you've got 2 at the top. And then at the bottom, this is a difference of two squares type of situation. So that will leave us with 1 minus cos squared x. But from the square identity, remember sine squared theta plus cos squared theta equals to 1. The square identity, sine squared theta can be written as 1 minus cos squared theta. So this is 2 over sine squared theta. That's or sine squared x. That's where it comes from. And you have proven the identity. So we are done here. Last question. Let's check this. All right, it will help. Last question is, determine the general solution of 510 in bracket theta plus 10 degrees equals to 4. Right, 3.7. Okay, we're supposed to find 510 of theta plus 10 degrees equals to what? Let's go back. 4. We're supposed to solve for theta. All right, step number 1. Let's find the reference angle. All right, so let's take everything to the right. Okay, so therefore, we've got 10 of theta plus 10 degrees equals to 4 over 5. Therefore, theta plus 10 degrees equals to 10 to the minus 1 of 4 over 5. That's the reference angle. Okay, we're going to round off correct to 2 decimals. Let's take a calculator. So that is shift 10, common fraction button, 4 over 5. And that gives us 38.66. 38.66 degrees. That's our reference angle. We're doing a reference angle for theta plus 10 degrees. Now, 10 is positive. In the 10 is positive in quadrant. Let's look at the cast diagram. Quadrant 1 and quadrant 3. Okay. In quadrant 1 and quadrant 3. Okay, let's see what happens now in quadrant 1. in quadrant 1, our angles are just expressed as the reference angle. Our angle, which is theta plus 10 degrees, equals to just the reference angle plus k times the period for 10 is 180 degrees, where k is an element of integers. All right, there we go. So now that becomes theta plus 10 degrees equals to the reference angle that we just calculated is 38,66 plus k times 180. Therefore, theta will be equals to, take the 10 degrees to the right hand side, that will be 38,66 minus 10 degrees plus k times 180 degrees, where k is an element of integers. Therefore, theta will be equals to 28,66 degrees plus k times 180 degrees, where k is an element of integers. We are done with the first quadrant. In quad 3, our angle theta plus 10 degrees is equal to the 180 degrees. That's how we express angles in quadrant 3. That will be equal to 180 degrees plus the reference angle plus the period, which is k times 180 degrees, where k is an element of integers. All right, then that will be equal to, therefore, theta plus 10 degrees will be equals to 180 plus, and the reference angle is 38,66, so that plus 38,66 plus k times 180 degrees. So therefore, theta will be equals to, you take the 10 degrees to the right hand side. Therefore, theta will be equals to 180 plus 38,66 minus 10 degrees plus k times 180 degrees. So take out a calculator and go. 180 plus 38,66. 180 plus 38,66 minus 10 degrees. That leaves us with 208,66. Therefore, theta equals to 208,66 plus k times 180 degrees, where k is an element of integers. You get marks for this, so don't forget it. Where k is an element of integers. Okay, now we check. We're going to check the first one. The one in the first quadrant, we're going to check it with quadrant 1. We're going to check the quadrant 1 solution with k equals to -1, just for control. All right, so we substitute it back into the original equation, so the left hand side must be equal to the right hand side. So that will be 5tan of, where it's theta, we left hand side 5 times 10, and where it says theta, we substitute the quadrant 1 angle, which is 28,66. 28,66, and then minus or plus -1 times 180 degrees. -1 times 180, or you can just say minus 180. degrees, and then plus that 10 degrees. All right. That should be equal to, let's see, take out a calculator. Let's go. 5, 10. All right, that is, it gives us 28,66. 28,66 minus 180 plus 10. And that gives us 4,00, which is 4. 4,00, blah, 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 which is approximately 4, which is equals to the right-hand side. So this one checks out. Let's check the quadrant 2, the quadrant 3 solution. All right, in quadrant 3, let's check the quadrant 3 solution with k equals to 3. All right, so that will be 5, 10. And then we substitute the quadrant 3 solution, 208,66. 208,66. All right. Plus 8 times 180 plus 10 degrees. Let's see what it gives us. Five times 10. Okay, so that is, let's see, 208,66. 208,66 plus 3 times 180, then plus 10. It gives us also 4,000, which is 4. 4,000, and that checks out. It goes to the right hand side. So therefore the solution is, we're not done. Therefore the solution is theta equals to 28,66 plus k times 180 degrees, or theta equals to, the second one is 208,66. 208,66 degrees plus k times 180 degrees. K times 180 degrees, where k is an element of integers, don't forget that. You get marks for that. And that's how you solve the equation. Question number 4. Given f of x equals to sine of 2x and g of x equals to 3 cos of x, 4x is an element of negative 90 degrees to 90 degrees. Sketch the graphs of f of x and g of x on the same system of x's in the given interval. Show all coordinates and intercepts and turning points. Okay, let's start with the graph of f. F of x equals to 2x sine 2x. That means in a period of 360 degrees, you've got 2 full. Okay, in a period of 360 degrees, you're going to have 2 full complete cycles. So 360, 90, 270. Okay, instead of one complete cycle, at 180 we're going to have a full cycle, so that will be there, 1, and then the other one. There we go. So at 90 degrees we're only going to have half. On the left hand side, same story. it will go there as well. That will be negative 90 degrees, so it will be like this. And the period, okay, there will be the range will be 1 and 1, negative 1, 1 and negative 1. So we will have here for 90 degrees it will be 1, it will be 1. At 45 degrees, where is 45 degrees? That will be 30. It will be somewhere in the middle. Yes, there will be 45 degrees. It will be peaking at 45 degrees. All right, so that will be 1 there. So it will be just like this. There we go. On the other side, same story. At negative 45 degrees, we will have the minimum turning point. And they meet like this. Okay. And the other part will be, there we go. So that is the graph of y equals to sine of 2x. Graph of x. Sine of 2x. Next, we'll draw the graph of g of x equals to 3 cos of x. This will be a normal cos graph with an amplitude of 3. So (360), and the period will be 360 degrees. So at 0, it will be 3. Okay, that's 180, 90, 270. So it will be 90 degrees will be, okay, and then it will be looking at, this is what it will do. Okay, between 0 and 90 degrees, it will be just going down from 3 all the way to, okay, from 3 all the way to 90 degrees. And then on the other side, it will be going down. So we're going to use, okay, let's just label this graph 45 degrees 1. All right, 0, 0. And that will be negative 45, negative 1. Okay, now let's draw the graph of 10, cos of x, 3 cos of x. We'll have the amplitude of 3, and it will go right all the way to, like that. And on the other side, same story. Okay, here we go. So this is the graph of y equals to 3 cos of x. G of x, 3 cos of x. And this is 0, 3. These are the coordinates. And this is negative 90, 0. Negative 90 degrees, 0. And that will be 90, 0. 90 degrees, 0. Okay. And that's how you draw these graphs. Okay, let's go back to the normal color. All right, let's go. Next is write down the period of f of x. The period of f of x, that is how many, okay, the period of f of x, period is calculated by 360 degrees divided by the absolute value of k, and that is equals to what? The absolute value of k is 2, so that is 360 degrees divided by 2, that will be 180 degrees. That is the period of k, meaning that it takes 180 degrees for one complete cycle to be finished. That is the period. Write down the range of g of x. Between these two, g of x has got a range of 0 to 90 degrees. The minimum is 0, it picks up 3. So the range is 0, 3. Or you can say y is between 0 and 3, including the endpoint. For which values of x is the product of the two negative or 0? All right. To the left-hand side, you've got one under the x-axis and another one over the x-axis. When you multiply the two, obviously they will give you negative because one is negative and the other one is positive. To the right of 0, both of them are on the positive side, so when you multiply them together, they'll give you a positive. So here, f times g will be positive, and here f times g will be negative. So this is where we are going to focus on the left-hand side. For which values of x is the product of the two less than or equal to 0. There's 0 here at 0 and at negative 90, and between the two it's negative. So it will be when x is between 0 and negative 90. 0 degrees and negative 90 degrees. And that's how you answer these questions. We're done with this question. Next question. Question number 5, trigonometry. Complete the following theorem. A line drawn from the center of the circle perpendicular to the chord. The chord, it bisects the chord. Bisects the chord. That's how you complete that. In the diagram below, O is the center of the circle and AC is the diameter. O is the center, AC is the diameter. There is the diameter AC. AC is produced to meet ED. AC is produced to meet ED way. There, at G, okay. OE is to CD. OE to CD, they're parallel. O is parallel to CD and angle B is equal to 72 degrees. Calculate, giving reasons, the size of angle C1. Angle C1. Notice that angle C1 is subtended by the same chord AD. The same chord AD that subtends 72 degrees angle D. Therefore, C1 equals to 72 degrees. This is question 5. That was 5.1. It's bisects. 5.2. 5.2.1a. 5.2, then 5.2.1a. Angle C1 equals to angle C1 equals to angle B, both equal to 72, and the reason is angles in the same segment. Angle C1 equals to angle B, which is equals to 72 degrees, and the reason is angles in the same segment. Okay, B angle O1, angle C1 are the same angles, forming corresponding angles because of the two parallel lines. They are there. OE is parallel to CB. For these two, O1 and C1 form corresponding angles. 72 degrees. Angle O1 equals to angle C1, both equal to 72 degrees, and the reason is those two parallel lines corresponding angles. Okay, those lines are parallel. OE parallel to CD, corresponding angles. OE parallel to CD, corresponding angles. Number C, D4, angle D4, angle D4. Okay, angle D4 and angle O1 are subtended by the same chord. Here is the chord AE. O1 at the center of the circle and D4 at the circumference of the circle. Therefore, angle D4 will be half of angle 72 degrees. Angle D4 is half of angle D4 equals to half of angle O1, and the reason is angle at center equals to twice angle at circumference, equals to twice angle at circumference. All right, and that is equal to half times 72, which is equals to 72 divided by 2. That is 36. Okay, let's go back, pencil it in. 36 degrees. All right, now AED angle AED will be equals to what? Right, AED is opposite angle B, so they add up to 180 degrees. D, angle AED is equals to 180 degrees minus angle B, and the reason is opposite angles, cyclic quad, supplementary. They add up to 180 degrees. So angle AED plus angle B equals to 180 degrees. Therefore, AED is 180 minus 72 degrees, which when you take out a calculator gives you 180 minus 72. 180 minus 72 minus 72, and that gives us 108 degrees. That's equals to 108. Let's pencil it in. 108 AED, that is 108. Next, the last one is angle D1. Angle D1 angle D1 okay, we know that this is 90 degrees. Sorry, this is 90 degrees. Angle ADC is equals to 90 degrees. Angle ADC equals to 90 degrees. All right, and then all of this are angles in a straight line. Angle D4 plus ADC plus D1 are all angles in a straight line. They add up to 180 degrees. Therefore, D1 will be equals to 180 minus both of those. Angle D1 will be equals to 180 minus 90 degrees plus 38. And that is sum of angles in a straight line. Sum angles in straight line. That is equals to 180. Let's just double check. Oh, this is 36, not, sorry, let's fix that. 36 degrees. All right, we'll go 180 minus in bracket 180 minus in bracket 90 plus 36, and that gives us 54 degrees. And that is the size of the angles there. D1 equals to 54 degrees. So let's go pencil it in. 54 degrees. You're done. 5.2.2, prove that AF is equals to FD. Prove that AF equals to FD. AF equals to FD. Prove that AF equals to FD. Alright, the best way to prove that AF is equals to FD is to show that the line that goes from the center of the circle, OE, is perpendicular to AD. How do we do that? Let's find the size of the angles. So we've got 72 degrees over here. All right, in this triangle ADC, okay, we've got this. Okay, let's find A. All right, A2. This is 5.3, 5.2.2. Angle A2 equals to what? Angle A2 is equals to 180 minus 72 minus 90. 180 minus 72 minus 90. 90 degrees plus 72. And this is sum of angles in a triangle. Sum of angles in triangle. That's the reason why, and that is equals to 180 minus 90 minus 72. That's 180 72. That gives us 18 degrees. Let's go pencil it in. That's 18 degrees. We've got this is 72 degrees, therefore let's see. Therefore angle A3 will be equal, no, angle F3, let's see, 180 minus 72 minus 18. Angle F3 equals to 180 minus 72 degrees plus 18, which is equals to 18, that 90 degrees. Good. 90 degrees. Therefore, this is 90 degrees, meaning that all of these are 90 degrees. OF is perpendicular to AD. Therefore, OF is perpendicular to OD. Therefore, Therefore, AF is equal to FD. Therefore, AF equals to FD. That is the converse of theorem 1. Perpendicular bisector. You can say perpendicular bisector. Perpendicular bisector. Next question. Is OEDC a cyclic quadrilateral? Give a reason for your answer. OEDC. OEDC. Let's see. Let's see if the opposite angles are equal. No, let's see if they add up to 180 degrees. This should be 180 minus 72. 180 minus 72. That's 108. Angle O2, 5.2.3. 5.2.3. Angle O2 equals to 180 minus 72 degrees. Angles on a straight line. That is equals to 180 minus 72. That is 108. Let's add the two opposite angles. So this is 108. Let's add the two. Okay, so 36 plus 90 plus 54. Angle O2 plus angle EDC. 108 angle O2. Therefore, angle O2 plus angle EDC equals to 108 plus that other one is 36 plus 90. And that gives us a total of 108 plus 36 plus 90. That is 234. Now equal to 180. So meaning that therefore opposite angles are not supplementary. Opposite angles not supplementary. Not supplementary. Therefore, it is not a cyclic quadrilateral. OEDC is not a cyclic quadrilateral. Therefore, OEDC is not a cyclic quadrilateral. Question 6. Complete the theorem. The tangent is to the radius drawn from the point of contact. It's perpendicular. That's the answer there. Use the diagram below. A, B, and C are on the circle with center O. PA is a tangent to the circle at A. Use the diagram to prove the theorem which states that angle BAP is equals to angle C. So here's the construction you make. Join. Okay, join. Okay, let's make that D. And join and CD 6.1. Okay, the construction. Join diameter AOD and DC. So now that you've joined them together, angle OAP is equals to 90 degrees. Angle OAP equals to 90 degrees. And the reason is tangent perpendicular to radius. Let BAP be equal to X and this be equal to Y. This be equal to Z and that be equal to W. X plus Y equals to 90 degrees. We've just shown that. X plus Y equals to 90 degrees, same reason. All right. So Z plus W equals to 90 degrees, angle in a semicircle. So X equals to 90 degrees minus Y. Z plus W equals to 90 degrees, and the reason is angle in semicircle. Angle in semicircle. Therefore, Z equals to 90 degrees minus W. But notice that W equals to Y, angles in same segment. There you can see they're subtended by the same chord, and there is the same chord. If you were all same arc, you can leave it like that, same arc, subtended by the same arc. But angle W equals to angle Y. But W equals to Y, and the reason is angle in same segment, angles in same segment. Therefore, x plus y equals to w 90 degrees. So now we've got w equals to y, therefore x equals to z. Therefore x equals to z. Both equal 90 degrees when added to w and y. And therefore we have proven. Therefore angle BAP equals to angle C. Therefore angle BAP equals to angle C. Proven. Next question. In the figure below, PQRS, a point on the circle, PR equals to SP. There it's drawn. Okay, let's just highlight that. Okay, let's highlight this too. They are equal. All right. They are equal. There we go. And angle U equals to angle P1. Angle U equals to angle P1. U equals to angle P1. There. Prove that RU equals to RQ. Prove that RU equals to RQ. All we need to do is to prove that angle Q1 equals to angle U. That's the goal. Okay, that is 6.3. Required to prove. We are required to prove that R equals to RP. RQ. RU equals to RP. Strategy, prove that the angles are equal. Strategy, prove that angle U equals to angle Q1. That's the strategy. How do we do that is the question. All right, let's go back. We are told that angle P1 equals to angle U. But angle P1 is also equal to angle R1. TAN-CHORD theorem. P1 equals to angle R1. TAN-CHORD theorem. TAN-CHORD. All right, but R1 is equal to this angle, RSP. Base angles of isosceles triangle, or you can simply say RP equals to SP. But R1 equals to RSP. Angle RSP angle RSP. Reason, the two sides are equal. RP equals to SP. RP equals to SP. Or you can simply say base angles isosceles triangle. That's up to you. Right, so P1 equals to R1 and R1 equals to this angle. But this angle, S, and Q1. Q1 is the exterior angle of the quadrilateral. But S equals to Q1. The reason is exterior angle, cyclic quadrilateral. Cyclic quad. Therefore, Q1 equals to U1 and U. Therefore, U equals to Q1. Meaning that therefore, the sides are equal. Therefore, RU equals to RQ. Therefore, RU equals to RQ, base angles equal. Reason base angles equal. And that's how you prove that. And with that, we've come to the end of this video and the paper. Thank you so much for watching.